Okay, hello guys, in the name of God, welcome to another solving problems in heat transfer issues. Okay, so this problems is problem number 77, as you can see here. But first, as previously as always, let me just introduce reference. The reference is Heat Transfer 10th edition from J.P. Holman, Professor Holman. Okay, this is a good book to solve these problems. First chapter is introduction, second steady state conduction in one dimension and multiple dimension has been presented in chapter 3. And unsteady state condition is in chapter 4, which we are working on that. Okay, so let us go to our problem, page 204. Okay, number 470-80-87. Let me read this problem to you. For the section shown in figure P487, this figure, calculate the maximum time increment allowed for node 4. Where is node 4? Here. In a transient numerical environment. So this is a transient, okay? A numerical environment, and also write the complete nodal equation for node 4, this point. Okay, let's get started and draw the picture of that. Okay, so here this is for actually material A, because as you can see in the picture, and this is B. Okay, and here we have some fluid convection, and this is conductive because these here are solid. Okay, these are solid. A and B are solid, but here is actually convective fluid. So H is 50 watts meter square 60 degree, and T infinity is 50 degrees Celsius. Okay, excellent. But I should okay, this is point 4. Here and here in this way. Okay. Okay. This is number 5. This is number 8. This is 7. 6. 3, 1, and last one, number 2. Okay, excellent. But let me just have some elements, okay, for all the points. Half of between 3 and 4, and 4 to 7, and 4 to 5. It would be something like that for this element. Okay, and for this one too, if will be here another point, it would be for number 2, and like that one for number 1. Okay, and so forth for other points. We have something like that here for number 7, and for number 5, element number 8, and so on. Okay, but what we should work on is just number 4. As you can see, it had 2 sections. One section here in material B, and another one here for material A. And as you can see in the picture at the right side of the window, we have all of densities and capacities of these 2 materials. But okay, let's get started. As before, I mentioned before, our formula for this problem is delta T should be smaller and equal than Ci equals 1 over Rij, which this is resistance, heat resistance, and Ci is rho Cp delta V. Okay, and about the dimensions, 0.728 here is 2 centimeters, and this is 1 centimeters. Okay, so this is 1 centimeters, and from this point to this point is 2 centimeters. We just have 2 dimension in here, 1 and 2 centimeters. Okay, then let's get started. Okay, so we want to write all of the formula for 0.4. Then okay, 1 R 1 to point 0.4 to 2. We should start with 2, the number 2. Okay, what do we have between 4 and 0.4, which is here, to 0.2? What do we have? Conduction, yeah. So what was the formula of conduction? Formula of that was Ka delta Y. Which K? K for material A or for material B? For material A, because here is material A and this one is material B, so K is for B, equals. Okay, so this is K for material, A. Material A is 7800. Okay, 7800. And what is A? I made a mistake. The K is not 7800, the K is 20. Oh, that was density. Multiplied by A. Which A? From here to here. Okay, this is A, which is 1 centimeters. Am I right? No, I'm not, because here to here is 1 centimeters. Here would be half centimeters. So I should correct it. Okay. And delta Y from point to 1 is 1 centimeters. Okay, it would be 10. Okay, next one. R4 to 3, element 3. Which one is element 3? That one, okay, this one. And this is point 3. From 4 to 3. What do we have? Again, K, A, delta, X this time. So what is K? Again, 20. What is A between 4 and 3? Yeah, exactly 1 centimeters. And what do I here? What do we have here? Delta X from 4 to 3. Just 1 centimeters. Yep. Okay, it is 20. Okay, next one. R4 to, let me go to 7, okay? Because we don't have any interface between 4 and 6. Just let me go for 7. Okay. Okay. It has 2 sections, you know? It has 2 sections. Because the top one is for material A, which is exactly the same as R, R42 is 10 for material A here, and another section is okay, another section is K A over, sorry, let me write it again, K A over delta Y. K is for material B, which is 2, and A is 1 centimeters, and delta Y is 2 centimeters. Am I right? Between point 4 to 7, 1 centimeters. Sorry. Here. 1 centimeters. Okay. It would be 2. Then for 7, 10 plus 2 would be 12. Okay? Okay. So another point. 4 to 8. Okay? But do we have any interface between 4 or to 8? No, and this is 0. Any resistance between them. Okay. But what do we have anymore? What else do we have? From R4 to convection, infinity here. Okay? And it has 2 sections. Formula is equals HA. It has 2 sections, okay? The H is equal and doesn't different. You are calculated this material A, or you are calculated this one. H is similar for both of them. And A, what is A? We should add these to A, okay? Here, from here to here is 5 0 1 plus 1 centimeters. Okay, it would be, the answer will be 75. Okay. Okay. Okay, what I need is to draw a table. Okay, let me change the color to black. R42 equals 10. 4-3 equals 20. R47 equals 12. R4 infinity equals 75. And R45. Okay, I should write it for 0.4. Okay, 0.45. R45 equals Ka delta x. Two oh 5, because here from here is the interface between points 4 and 5, and delta x is 2 centimeters. The answer will be 0.05. Okay, I will write it here exactly because I need these after that. Okay, 0.5. Okay, sigma 1 over Rij equals 43.25. If I add all of these together, the answer will be 43.25 for 0.4. Okay, let me just erase all of these because don't need them anymore. Okay, next step is to calculate C1 equals rho 1 CP1 delta V1. Oh, I'm sorry, 4.4. Okay. Okay, for material A, 7,800 multiplied by 500 CP. As you can see, okay, here CP is 0.5 multiplied by 1000 would be 500 joule per kilogram. Okay, this is for that. And delta V, what is delta V of that? Oh, 0.005 from here to here multiplied by this distance, which is 1 centimeters. Okay, plus 1600, which is this density multiplied by this one, it would be 800, and this one from here to here is 0.005 multiplied by this distance, which is 1 centimeters. Okay, the answer C4 would be 259. Okay, so I will write it here. C4 259. Okay, I'm done, nearly done, but not completely. I should write the formula delta t smaller than 259.43.25. It is 5.988 seconds. Okay, this is okay. Another time I will write the formula nodal equation, transient equation here for you. TIP plus 1 equals QI, which is 0 in this problem, multiply sigma J TJP equals divided by RJ delta T over C I plus 1 minus delta tau CI sigma 1 over Rij Ti in time P. Okay, we should we should put all of them in here, in that. Okay, we assume that all the points, for example 1 2 3 4 5 6 7 and 8 in the 0 time would be, for example, okay, we imagine all the time in 0 in the time 0 first time, initial condition. For example, imagine all of them are 2000 degrees Celsius. Okay, so we want to write it for 4.4 T4 and P is 0. Okay, first okay, it is equal, Q is 0 in this problem because we don't have any generation source. Then we don't write it anything in place of that. Okay, we should write all the points we have in here. Okay, as we said, all the temperature are 200 degrees Celsius. This is for TJ and R1J for all of them. I can write all of them. Okay, and multiply all of them by each other. So if I add all of them and put it in this formula, it would be 43.25 for this one. Okay, because this is TJ, all is 2000, and this RJ, this would be like that. Okay, delta T, delta tau is 5.988, and what is CI? 259. Sorry. Okay, plus here 1 minus 5.988 multiplied by 259, again 43.25, this one, and TIP. See the value of that? It is T40, as I said, 2000 degrees Celsius. It is called uniform temperature. it means all of them are 200 or the same temperature. Okay, the value of that would be for T for 1, everything it would be 240, like that, just like that. Okay, and I forget to write something here. Okay, what is that? I should here, exactly here. Let me erase this formula. I hope you land it, you have landed, but I forgot to write something here. Plus I have another thing here, the temperature of T infinity multiplied by R for infinity. Okay, T infinity is 50 and R infinity is 0.75. Okay, I should add this value to these ones, and all like before, 988. Okay, this was nodal equation. Thank you for watching the solution of this problem. Have great day or night. I don't know exactly what's the time in your country. Take care, have a good one, bye bye.